Hello, Hornets, and welcome. We're going to be taking a look at classwork or assignment number 8 today, which is found on page 385. And we're doing numbers 1 through 8, 13 through 35, odds, 41 through 51 odds, and then 73 through 77 with n equaling 2. Please be aware I am not doing the entire assignment. I am only doing a smattering here and there, and if that is not good enough, I am sorry. But this is my 8th attempt at trying to do this, and I have no doubt that the lights will go out before I am done, which will stop me again. This time, however, I am going to finish, and nothing short of death is going to stop me. So we're on page 385. I'm doing number 1 again. I am given y equals ce to the 4x. I am trying to show that y prime is indeed 4y, so I'm taking the derivative y prime, which is 4c e to the 4x, and I am replacing with ce to the 4x with the given y. Notice I get 4y. That's what we're looking for, and we move to number 2. See, it's all about manipulation and algebra. That's what they're trying to get you to do. So y equals e to the negative 2x, and we're trying to show that 3 times y prime plus 5 times y will equal negative e to the negative 2x. Since y prime is equal to negative 2e to the negative 2x, by substitution I can get 3 times negative 2e to the negative 2x plus 5e to the negative 2x, which gives me negative 6e to the negative 2x plus 5e to the negative 2x, and I am left with negative e to the negative 2x. And it checks. Going to number 3. Number 3 is giving me x squared plus y squared equaling cy, and I want to show that y prime is equal to 2xy over x squared minus y squared. Taking my derivative, 2x plus 2yy prime is equal to cy prime. Moving the 2x to the right and factoring out y prime from the 2y minus cy, I'm then looking at y prime is equal to negative 2x over 2y minus c. I'm going to multiply by y over y. We know that because we got a y in the numerator. Y prime is then negative 2xy over 2y squared minus cy, and I can now replace cy with x squared plus y squared. Y prime equals negative 2xy over 2y squared minus x squared minus y squared. Simplifying gives me y prime equals negative 2xy over y squared minus x squared, and I can now distribute the negative from the numerator into the denominator to make it 2xy x squared minus y squared, and that's what we're looking for. Yay! We now go to number 4. Number 4 is taking y squared minus 2 natural log of y equaling x squared, and we want to show that y prime or dy dx is equal to xy over y squared minus 1. Taking my derivative, 2y prime minus 2 over y times y prime is equal to 2x. Factoring out y prime, I get 2y minus 2 over y equaling 2x. Getting the common denominator, y prime, 2y squared minus 2 over y, allows me to multiply by the reciprocal, so that y prime will then equal 2x times y over 2y squared minus 2. Factoring out the 2 and reducing it with the numerator, and I have xy over y squared minus 1, which is what we're looking for. Now, when you go to number 13 through 19, odds only, please beware they are trying to get you to show that the fourth derivative of y minus 16 times y will actually equal 0. So if you take 13, where they give you y equaling 3 cosine x, they want you to find y prime, which is negative 3 sine x, y second derivative, double prime, is negative 3 cosine x. Y triple prime is positive 3 sine x, so that the fourth derivative is 3 cosine x. I can now put this in as 3 cosine x minus 16 times y, which is 3 cosine x, and this is supposed to equal 0. You'll notice that 3 cosine x minus 48 cosine x does not equal 0. In fact, it equals negative 45 cosine x. So the answer is no, it is not equivalent. 15. 15 is giving me y equal to 3 cosine 2x. And I'm going to follow the same basic principle. So y prime is giving me minus 6 sine 2x. Y second derivative is giving me minus 12 cosine 2x. Y third derivative is giving me positive 24 sine 2x. And then the fourth derivative is giving me 48 cosine 2x. Putting this into my formula, I get 48 cosine of 2x minus 16 times 3 cosine 2x. Now you'll notice I end up with a 48 cosine 2x minus 48 cosine 2x, and this does indeed equal 0, and so the answer is yes. Going to number 17. 17 is giving me y equal to e to the minus 2x. So y prime is minus 2 e to the minus 2x. Second derivative is positive 4 e to the minus 2x. Third derivative is minus 8 e to the minus 2x. And the fourth derivative is 16 e to the minus 2x. This is giving me 16 e to the minus 2x minus 16 e to the minus 2x. And we can clearly see that this is indeed equal to 0, and our answer is indeed yes. Let's move on to number 21, please. Number 21, they are trying to show, and we want to make sure that x, y prime minus 2y will actually equal x cubed e to the x. And it's a yes or a no. So in number 21, we are given y equals x squared. Y prime is therefore 2x. And when I put this in, I end up with x times 2x minus 2 times y, which is x squared, is giving me 2x squared minus 2x squared, and that's 0. So the answer is no, it is not going to equal x cubed e to the x. Let's take a look at number 23. Number 23 gives me y equals x squared e to the x. And when I do my y prime, I'm looking at 2x e to the x, and I have a plus x squared e to the x. I can factor out e to the x, leaving me with a 2x plus x squared, and I can now put this into my form. So I have x times e to the x times 2x plus x squared, and then I have minus 2 times x squared e to the x. And I want to show that I have an x cubed e to the x. When I distribute, I have e to the x times 2x squared plus x cubed minus 2x squared e to the x. This is giving me 2x squared e to the x plus x cubed e to the x minus 2x squared e to the x. The 2x squared e to the x is canceled, and I'm left with x cubed e to the x does indeed equal x cubed e to the x. That is therefore a check or a yes. Number 25 is going to follow the same basic pattern that we just did here. So we're taking a look at y equaling sine of x, which means that y prime is cosine of x. We're then going to do our x times cosine of x minus 2 sine x, and this is supposed to equal x cubed e to the x. It is very clear that this is not equal, and the answer is no for number 25. Number 27. Number 27 is now asking you to work with y equals the natural log of x, and therefore y prime is 1 over x. So putting this together as x times 1 over x minus 2 times the natural log of x, and notice this is 1 minus 2 natural log x, which is in no way equal to x cubed e to the x. The answer is no. I'm now moving on to the next page. So I'm taking a look at number 41, where we are trying to find our general solution, and we are given dy dx equals 6x squared. I'm going to start by separating my variables. So I have dy equal to 6x squared dx. I'm then going to integrate dy. I'm going to integrate x squared dx. I get y equal to 6 divided by 3x cubed plus c, and the general solution is 2x cubed plus c. And this is the way they are going to work for numbers 41 through 51. Hornets, this ends this video. Individuals who have other questions from various parts of this should come in and ask, as this is merely a general use of our process. Hopefully this has helped. If it has, please click like. If not, please give suggestions. And thank you very much. Have a very good evening. Good night, Hornet.